Well, hello and welcome to the third lecture here in our lighting class this fall. This one talks about measurement of light, and that corresponds to the chapters in our book numbers 17 and 7. And we're going to start with number 7, which is measurement of light. And there's a couple of terms that you really have to nail before you can get the exact sense of what we're doing here. The biggest thing, we talked a little bit about luminous flux. That's the number of lumens that come out of a light bulb, a lamp. And that's usually printed on the box. It's actually required by law for light bulbs, again, measured in lumens. There is another element of light sources called luminous intensity, and that's light flowing in a specific direction. So luminous intensity, if you were to draw a metaphor of like a garden hose, luminous flux is just the total amount of water that's coming out of the garden hose. If it's attached to a sprinkler, a sprayer, or whatever, just a total volume, gallons per minute. Luminous intensity is how many gallons are going in a particular direction. So there may be a lot of water coming out of the garden hose, but if I'm not standing in front of wherever it's spraying, I'm not getting wet. And so the corollary is with a lamp, many are directional. They're not omnidirectional, they are unidirectional or have a narrow focus. So in those lamps, they may put out the same luminous flux as an omnidirectional lamp, but you may not be seeing any light in the direction you want. So they can be aimed, is the upshot. Okay? Luminous intensity is one of the features that we use to calculate light levels on different surfaces. Anyway, there's a number of other things that we have talked about, including illuminance. That's the measure of light landing on a surface, measured in lux or foot candles. Foot candles in the US, lux everywhere else on the planet. And you might hear in the book them talking about luminance, which is different than illuminance. That's basically the amount of light reflecting off of a surface. And you can try to use your phone as a light meter to determine luminance, reflected light, but it generally doesn't work particularly well. You can only get a broad sense. Illuminance, on the other hand, the phone works pretty well. All right, so let's talk about how these things are described. Luminous intensity, like I mentioned, it's directional, and it's typically by the lamp. But nowadays, because of LED lamps, those are typically the light source is integral with the fixture, with the luminaire. What that means is you can't change the lamp, you can't change the light bulb. And when you get the photometric data, which is to say the information about how light comes out of a light source, you'll see that it looks exactly the same. So this chart that we see here is pretty typical. It has a 360-degree kind of protractor on there, and then some kind of curve drawn. In this case, here's my cursor. The curve is describing a pattern of light. So in the vertical direction, in this 90-degree direction, which looks mirrored, you can measure from the origin down to the point in the curve, and that's the actual volume of light coming out in that direction. What you can see is if you measure here at 120 degrees, that the distance from the origin to the point where the curve intersects the graph is much smaller. So there's less light coming out in that way. And you can see it on the wall, but we obviously can read the chart too. And there's any number of different light distributions, and many of those look exactly the same. This is from Urco, a manufacturer, and you can see these different light fixtures produce very different light patterns, and they're all LED. So it's the same source, same color temperature, same color rendering, just the pattern of light is different based on the way the fixture is constructed. And this is actually from a computer program. I believe it's V-Ray. These are the virtual lights that you can create inside a rendering program. They are meant to mimic what you see in reality. So what we see nowadays, because of computers, we'll see these charts. They're called polar candela plots. or just photometric data. You'll see those from manufacturers. You will sometimes see a three-dimensional representation of the light output. These guys call them a photometric solid. This curve is a little more descriptive than this diagram, which indicates kind of an X and a Y axis pattern of light distribution. This is actually the three-dimensional light distribution. Again, the quantity of light coming out of that source in any angle, any polar angle, so 360 degrees, rotated around 360 degrees, can be measured by a point on this kind of weird, shape. Anyway, some manufacturers, this last one was from Edison Price, will show it as a chart, a little old school there, but again, you can look it up based on the angles, and that's also helpful. So, and lamps, lamps come in any number of different shapes, and so the light output that you're going to get from these different lamps is quite different. And again, I will keep reminding you that LEDs kind of change the way light fixtures work in the 21st century. You don't have lamps per se with LED fixtures, but the vast majority of equipment installed these days is historic, and it uses these types of fixtures. Anyway, the different light sources, the big difference is that these types of fixtures with a glass bulb, hence the name bulb, are more or less omnidirectional. Ones that have combinations of types of reflectors of various flavors are typically unidirectional with some sort of beam spread specified. So, and these sorts of things, even in a lamp, in the old school plug-in lamp, the Luminaire does matter. This is an adjustable fixture with a spread lens, a lens which softens the light and spreads it. And these are used when you have lighting critical tasks, typically something like artwork, where it's very important to get it exactly right. All of this information does, in fact, show up on the box for your typical lamp, or on the box of the Luminaire. I liked this particular one from Sunlight just because it shows you the basic facts. Here's the number of lumens, an estimated amount of cost, which is kind of silly. The lamp life, okay, 27 years. What it doesn't tell you is the actual number of hours that they are rated for, although this one I know is probably around 25,000 hours. And then the color temperature, and of course color temperature we learned about in the book, and color rendering. You can get this sense of what they're talking about based on the image here. So let's talk about the numbers now. First of all, the rule number one with lighting is the farther away the light source, the less light that you're going to get landing on a surface. So if you double the distance from a surface, if you take a light bulb, a lamp, and move it up, you'll get half the amount of light. And that's known as the inverse square law. So if I double the distance, I get 1/4, or 2 squared, the brightness. And what does that look like kind of more architecturally in terms of a section? Well, if you take a mounting height and you double it, the amount of light landing on a surface, again, this is the surface down here, is going to be 1/4. So here at mounting 2.4 meters, you get 420 lux. Up here, doubling the distance 5 meters, you only get 90 lux, so roughly 1/4. So that is the basics of kind of measuring light and the numbers that we're looking at. Now we're going to talk about design verification. Okay, and what that basically means is calculations. Do you get what you hope you're going to get? I like to think of it as what to buy. Back in the old days, you could change the characteristics of lighting by just swapping out the light bulbs. If you changed a par 38, if you change it from a 50-watt par 38 to a 150-watt par 38, you'd get a lot more light. It was easy. Nowadays, it's a little different because of LEDs and the way they function. But basically, the features are the same. First thing is, what's the appropriate light level? What's the target light level? Then you have to choose the calculation technique that is appropriate for whatever it is that you're trying to figure out. And then choose a lamp and or luminaire. And finally, do your calculation and revise it so that you get the correct light level. So first of all, what are the light levels that are recommended in different areas? From our friends at IESNA, Illuminating Engineering Society of North America, they publish standards. Again, these are guidelines. You don't have to, you're not going to get spanked if you don't follow them exactly. But they're great for when you're trying on a new space for design and you just don't know how much light you should put in there. Things like public spaces, lobbies, and that sort of thing. 3-foot candles is a fine recommendation. For visual tasks of high contrast, this might be something like reading a book. You're looking at 30-foot candles. And detailed things like making models is probably 100-foot candles. So these are general standards. They also publish a detailed list. I put this on Canvas. So different spaces, you can have different very specific recommendations. Exhibition halls, elevators, drafting rooms, all these things. They basically figured out, all right, what do you do in there? And then what's the recommended light level? There are so many other factors that go into it, including surface colors and textures, location of windows, that sort of thing. These are obviously guidelines which can be broken, but they certainly give you a good sense that an operating room has 300-foot candles. That's a lot of light. Whereas a barber shop, which obviously has a fair degree of detail, but not quite the same level as surgery, we hope, is only 50. So, all right, let's talk about the different types of calculations. There's basically 4 that you as an interior designer might find yourself in the situation of having to do. The first one is what's called a point source calculation, and that's common if you're just trying to light, say, a painting or a piece of art from a single light source, or possibly 2 light sources. Okay, one called an area method of calculation, otherwise known as zonal cavity, which the book refers to in chapter 17, is usually what you use for a whole room. Typically, this is good for general lighting. What we do early on is use what are called rules of thumb, which are basically simple rules that kind of average out the type of fixtures. And these are great when, one, you're trying to get your Revit model to work, or at least have the reflected ceiling plan look correct. But before you've chosen an actual product, okay? For doing the zonal cavity method, you typically do use a product. Anyway, the last one that we often do is energy usage. The building code in Massachusetts and most states now requires a maximum level of energy usage measured in watts per square foot over different project types. So let's take a look at a point calculation. Typically, you have 1 or 2, maybe 3 luminaires. Very common for paintings or architectural features, floor patterns, mosaics, arches, signage, things that you want to highlight as brighter than the adjacent surfaces. Okay, and there's a fairly simple formula. Illuminance in foot candles on the surface you're trying to light equals the candle power. Now remember, this is the luminous flux, the directional light coming out of a light source, divided by the distance squared. Okay. Now the reason it's so important to understand this luminous flux idea, this candle power, is that different light sources have different beam spreads, and so the same amount of output narrowed in a narrow spot is going to be much brighter on your surface. Okay, so the formula is fairly general, but it gives you something that you can work with, and the biggest thing for us is you just have to draw it up. Okay, this is straight out of Revit. You figure out, oh, here's a mosaic on the floor. How big is it? Well, you know it because you're designing it. How high are my ceilings? Well, you know that because you're designing them. And then you just pick, you measure the beam spread that's required from that light source, recessed or whatever. And that gives you all the numbers you need. Then you know, well, if it's a lobby, it's probably 3-foot candles based on the IESNA recommendations. I want my mosaic to be much brighter, so I maybe will light it with an additional, say, 3 times as much, 9 or 10 foot candles. Then you just run the numbers on different lamps. Now, one thing to consider, and the book also talks about this, is that the angle of the light source, sometimes, as in the case of a mosaic on the floor, it's just straight down. There's no problem. Facing, so the surface you're lighting is perpendicular to the line of, center of the line of candlepower, of beam of light. What happens when you have a painting mounted vertically on a wall where there is some angle between the light coming out of the fixture and hitting this object, or on the floor, same thing. There is some angle formed, so your calculations get thrown off. This is where we get to do a little bit of math. And again, the basic formula is the same. The luminous flux divided by the distance squared, but now you adjust it for the cosine of theta, so the angle diminishes the amount of light landing on the surface. So you might say, well, how do I even know how far away it's going to be? There are certain basic rules of thumb. If you remember from the last lecture, I talked about the optimal angle to avoid brightness and veiling reflections. That's 30 degrees off of the vertical is the mounting of the light. So if you're standing here, you'll won't get glare. Also in plan, 45 degrees from the center of the object you're lighting if you are using 2 light sources. Anyway, so what you need to do, basically, I can't remind you enough that drawing it up is the best way. But if you're just like whipping out your floor plans and you say, oh, I'm going to spotlight some object on the wall, a clock or a painting, you can use these rules of thumb to say, oh, I have 20-foot ceilings. I need to mount that directional light 8'7" off of the wall. And what this helps you do is avoid things like putting soffits where they shouldn't be, or having light sources where they're not going to work. So, anyway, again, I cannot recommend enough that once you have figured out the dimension of things, if it's a logo or a banner, draw it up and see if you can figure out the exact angle. The rule of thumb for mounting this light source off the wall still applies. 12 feet off the wall, or 12 feet off the floor, gets you 4 feet off of the side wall, just off the previous chart. Again, the perfect 30-degree angle for my light source. The only difference here is that the size of the object is larger. Now, another thing to consider, I often will have 2 light sources lighting a larger painting, one from the left side, one from the right side. The illuminance is additive. So let's say I run my calculations and I find that I'm getting 10-foot candles on this painting from one of these light sources. Well, if I have 2 of them, once I add that second one, the light level is doubled. It is, in fact, additive. It's not just sort of a little bit more. It's quite more, which is different than something like, say, sound, where it is not quite additive due to the scaling of how you measure sound. All right. So when you have multiple lights in a row, something like a corridor, you're going to want to use rule of thumbs when you're first laying them out. Rules of thumb. And the basic rule of thumb for downlighting from recessed cans, which you can picture here down at the bottom, some sort of can or suspended fixture. It's going to have some kind of beam spread. So the ideal is to get an even level of lighting either on a work surface or on the floor. The biggest thing is whatever you're trying to light evenly from these recessed cans, that height is the mounting height, MH, and the spacing ratio is how far apart these guys should be. Now, the rule of thumb is just use 1. So if you're downlighting a corridor and the ceiling height is 10 feet, the spacing, S, is also 10 feet, okay, because the spacing ratio is 1. If you're lighting, tabletops that maybe the mounting height is only 8 feet, then your spacing ratio is 8. What you'll find when you go to the manufacturers is that they publish spacing ratios for their different fixtures that you use in all sorts of different settings. Again, there's low glare fixtures. There's fixtures that are designed for different situations like work surfaces. They're still recessed downlights, but they have different applications. So anyway, another thing that you do with repeated luminaires is wall washing, which is not keeping your walls clean, but instead just making a nice even illumination on the wall. And we saw some of this on our field trip. The basic rule of thumb is pretty straightforward. The distance from each other and from the wall is based on the mounting height. Okay, and the reason for that is that's the height that you're trying to light. Most wall washers are designed to be mounted 1/4 of the wall height away from the wall. If you get closer than 1/8 of an inch, 1/8 of the height of the wall, that's generally considered grazing light. Okay, so it's what's going to bring out texture, but won't produce quite as even a light. So graphically, what that looks like, you have the spacing is 1/4 the height of the wall, so S equals 1/4 or H over 4. S here equals H over 8. Okay, so you can see the same wall, same height, their mounting is going to be a lot less. Anyway, and the distance from the wall is actually half of whatever this is. So just to hit it home, since we do a lot of wall washing, if you have a 12-foot ceiling height and you want to wash a wall, presumably the whole wall, how far apart do the light fixtures need to be? Well, they are 1/4 of 12 feet. Okay, so that works out to 3 feet. So mount them did I get that right? Yeah, I got that right. 3 feet from the wall. Okay, and the grazing light is going to be half that. Now, what about other things like a cove or a slot? There's other ratios that are going to work. Again, a lot of times when you design these, you'll model them in the computer, but you'll also use manufacturer's equipment where they have very specific mounting recommendations. Anyway, so that's when you have multiple repeated types of fixtures, typically point sources. What if you want to light an entire room, which we call general lighting? Okay, when you're not trying to light specific objects, but just kind of flood a room with light. The best method for that is what's called the zonal cavity method, which divides the room up into zones, and each of those zones has a kind of room cavity ratio. And it takes into effect a number of different things, how efficiently the fixtures work, which is called the coefficient of utilization, the light loss factor. A lot of light sources diminish their output over time, lamp lumen depreciation, and then finally dirty light fixtures, Luminaire dirt depreciation, which is a real problem with certain types of light fixtures, particularly uplights. If you're uplighting corridors, that's a nightmare. So I will not be covering every single element of this, but the basic formula is the light level in foot candles on whatever work surface you want equals, here you go, number of lamps times the initial lamp lumens times the light loss factor times the coefficient of utilization divided by the area. Okay, got that? Now it gets even worse because as you start to look at all the elements that go into this, for example, the reflectance of different materials, well, you realize that pretty quickly things like furniture can vary wildly in how reflective it is just based on the material. In fact, if you look at the reflectance of different materials, it's kind of shocking. Some materials you think, like wood, how bright could wood be? Well, wood could actually be pretty reflective. Light birch can be up to 50% reflective, depending on how it's treated. Whereas obviously mahogany, you'd expect that to be dark. But some things like stone can actually be brighter than or more reflective than concrete. Again, it depends on how it's treated. So it gets kind of ugly. And this is kind of the logic behind the way this works. There's a cavity in different parts of the room, and it calculates how the bouncing of light goes in these different cavities. And there's a whole form, which the book has, which is, again, this is very old school. It's kind of painful, frankly. And once you plug in all the numbers, then you end up with some number. Again, all this stuff are things that you can look up or calculate. For us, what we're going to do almost certainly in class is to use an online calculator, which does all this stuff for you. You put in the dimensions of the room, you choose a luminaire, so there goes all the data that you need in terms of light output, lamp lumen depreciation, and light loss factor due to dirt and all that other good stuff. And then you specify the illuminance, and the computer will actually lay it out for you. Now, obviously, it only works for certain manufacturers, so there's a certain limitation to it. But boy, this is a lot handier than filling in all those pages of paper. If you're like, well, I just want to get this laid out for my presentation tomorrow, then there are certain general rules, fluorescent general lighting, general rules of thumb. Every fourth cell, both directions. There you go. You're done. Okay. Does that work every time? No, of course not. A higher ceiling means either you're going to have super bright fixtures up there, or you're going to need more of them. And lower ceilings, obviously, you're going to have to use low glare fixtures, which are less efficient at getting light out of them. But that's a general rule for fluorescent, what are called troffers, those boxes up at 2x2 ceilings. With the advent of LED troffers, they're meant to be low glare fixtures that replace these fluorescent ones. For now, the rule of thumb is about the same. Okay. The last type of calculation you do is actually pretty irritating. It's the Massachusetts Energy Code, CMR 780, Commonwealth of Massachusetts Regulations. Section 1308.1, lighting criteria shall apply to lighting for the following interior spaces. And there's a number of different things which you can read at your leisure. But basically what you get is what's called a power allowance. You're back on an allowance, and the state of Massachusetts will tell you exactly how to calculate that allowance. For most of us, we can probably leverage our software to get us this answer. So let's say you're working on a hotel, I believe is what the juniors are working on, undergrads. You're allowed 1.7 watts per square foot. So what you do is you add up all your fixtures and how much wattage each one uses, and then you divide it by the square footage of the project. Now, there are more subtleties to it, and if you're finding that you're very close, and it's an important project, you would obviously want to call an electrical engineer or a lighting designer to do a more detailed calculation. But for our purposes, you can do this by basically using your light fixture schedule in Revit, and it will add it up for you. It'll multiply through the number of fixtures occurring in your project, and it'll give you a pretty good ballpark. Okay. Usually, this isn't such a big problem for most types of facilities. However, things like museums and retail can actually be really hard. And the reason is because retail, there's just a massive amount of light required, especially when there's a lot of daylighting that you're trying to counteract. Now, LED light sources have helped us with this immensely. However, it's not a guarantee that you'll get there. So, in summary, the important thing, probably the most important thing for you as an interior designer is to know the appropriate light levels. If you go to a manufacturer's rep or you go to a lighting designer and they say, oh, well, what kind of light level you want to get on there, you need to be able to understand what it is that they're telling you. For sort of in-office work, absolutely, you can do point source calculations. They're not that hard, and we will learn how to model them on the computer. So you don't really have an excuse. And then for things like if you're working on a school, very commonly you will call up manufacturers' reps and say, all right, what can you do for me? And here's the light level I'm shooting for, and they'll give you some options for different fixtures. Okay, because in situations like that, it's the options are extremely varied, and also the cost implication. You're just not going to know about that. So anyway, I cannot emphasize enough that if you have a complex situation, retail would be an example, or a museum. are examples where a lighting designer would be really important to hire because the calculations are just too complicated, but it's very important to get them correct because the light levels on in these situations are actually really critical.